Welcome back. In this video, we will cover split, apply, combine operations. Now that sounds very complex, but in reality, it is something very simple and intuitive. In Python, the primary way you apply the idea of split, apply, combine is through pivot tables. So if you are already familiar with them through, for example, Excel, then this should be relatively straightforward. The reference to the idea of split apply combine was made popular by Hadley Wickham, who has written many super useful packages for the R programming language. And conceptually, the process involves three sequential steps. For example, imagine our diamonds data set. We know there are 7 different types of possible colors for a diamond, and these are labeled as letters D, E, F, G, H, I, and J. So there are 7 of these. And we may be interested in examining the data separately for every color. For example, we may want to know what is the average price for a diamond that is color D as opposed to the average price for a diamond that has the color E. And obviously, one way to do this would be to filter the data for the first color, say D, and calculate whatever we are interested in and note it down somewhere. For example, we may be interested in the average price of a diamond by color and the median weight or the caratage of the diamond. And once we have calculated these values for color D, we can then move to the next value of color, which is E, and do the same thing. And when we are done with all of these tedious repetitive iterations, we can combine all of our different answers to come up with a data table of sorts that lists for every color what the average price and the average weight is, or the median weight is. Now, if you take a step back from what I just described, this is what we did. First, we split the data, which means by color, and then we found 7 separate buckets of data, one for each color. After that, we applied the function mean to price and the function median to the weight or to the caratage. Finally, we combined the data into one set as a complete answer to knowing the mean price and the median weight by color. And that exactly is what split, apply, combine means, which means you split the data, you apply a function, which in this case was mean or median, and then you combine the results for each of the splits. So let us see how we can do this with pivot tables. And pivot tables, they allow us to summarize information in a very nice way. Python functionality to create pivot tables is pretty much identical to the pivot table functionality you have seen in Excel. So first let me show you and remind you how it is done in Excel, and then we can look at doing the same thing in Python, and that just makes it slightly easier to comprehend. And with that, I am going to begin sharing my screen. Like so. So let's load some data. Let's look at our empty cars dataset, which we have previously loaded in this notebook. Again, for this lesson, we are going to use the same notebook, Lab 3, Exploratory Data Analysis, the one that we used in the prior video. So we are continuing with that. Our empty cars dataset, this has these 32 cars, and there are all of these different columns that contain attributes for each of these models of cars. Again, don't pay too much attention to the data. These are not recent cars. These are from the 1980s, and may not, the data, the values themselves are really not important. That's what I'm trying to say. Let me also point out one more thing here, and that is that here in this data frame, these here are our columns, as you know, and these are the column names. These are the different column names. In the same way, our rows also have labels or indexes. These are the indexes. So these are called the index values. Normally you would often see 0, 1, 2, 3 numerical indexes, but you could also have strings or dates as your index value. So I just wanted to point this out. And here we have our columns. Sorry, that disappeared, but you get the idea. So we will be using the idea behind indexes and columns going forward in our uh, discussion. So I just wanted to make sure you understand what an index is and what a column is. So these are indexes and these are columns. So the rows have index and columns are just columns and column names. So this is our data set, and we would like to create a pivot table on that to summarize it. One of the things we will do in our data frame is we will change some of the columns to become a little more intuitive for exploring pivot tables. So one of the things we will do is we will replace cylinders, the count of cylinders. So for example, if you look here, our cylinders are either 6, 4, or 8. So we have 6, 4, or 8 cylinder cars. So instead of the number 6, we will replace it with the word 6, SIX, and so on. And similarly, for the transmission, automatic versus manual, which is currently indicated by a 0 or a 1, we will replace it with either automatic or manual. And that will help us understand the pivot table functionality better. So we do this here. We replace the 4 with 4, 6 with 6, and 8 with 8. So it's a small minor transformation to the data that we do here. And once we have done that, we look at our data frame and we can see that the that the transmission is now either automatic or manual, and the cylinders have now been replaced by the numbers. So once we have done that, because I'm going to show this to you in Excel, I'm going to export this to a file in Excel, and I will open the file in Excel so we can look at how to construct a pivot table in Excel. So I export the file in Excel, open it here, and this is what my file looks like. So these are all my index values in bold. These are my columns, and here is the same information that we had in our data frame. So identical information to what we had in the Jupyter notebook. Let me actually place these side by side so we can see both of these things, and I'll hide the table of contents so we have more information available here. So we have this, and what we want to do is we will create a pivot table. We will create a pivot table in Excel, and then we will see how to do the same thing in Python, and that will make it easier for us to understand. So this is where we are on the Python perspective, and let's just do that here. I'm now going to insert a pivot table by clicking on Insert Pivot Table, and it selects the range for me. By default, I insert it into a new sheet, and here is my pivot table. And what I want to do is I want to look at my gears. How many gears does my car have? I also want to look at cylinders, the number of cylinders it has, and I want to see the average weight. So I'm defining here in Excel, I'm defining the rows, and I'm now defining the values that I want to see against each of these, and this is the weight. And currently it is showing me the sum of weight, which is not very helpful. So I can change the value field settings to average, and I get this. I'm also going to change the layout of my pivot table to classic so that I get to see how I would see the data in Python. I'm also going to remove these subtotals because that's not how Python will do it. And I want to be able to match the numbers. So I can do pretty much the same thing by specifying the index, which is in Excel is rows. And I can specify the values by putting in here exactly what I specified for values here. So average or weight here. And by default, the function that it applies that Python or Pandas applies in a pivot table is mean. So I don't have to say that this has to be a mean. It can be, I can leave it just like that. if I wish to apply something else, in fact, for example, if I wanted to sum it, then I would have to explicitly ask for it to do a sum, and we will look at that in a moment. So when I run this, I get exactly the same pivot table that I see in uh, in Excel, and you can see that the numbers are identical, except that here I see a grand total and there are some presentational aspects which are slightly different, but I get the same information here uh, in Python as well. I can do a little bit more analysis this time. I did not have anything put in columns here, and maybe I want something here in columns. So maybe I want my cylinders to be in columns. So I can drag and drop in Excel. I can put the cylinders in columns. I can put the automatic versus manual also in rows. And I get a table that looks like this. Again, I remove the subtotal just to make it cleaner. And I can do the same thing here, and I get the same numbers and the same answers as I do in Excel. So you can see that here we are following exactly the same format as we would in Excel, except that instead of rows, we call it index. Columns are still called columns, values are still called uh, values. And one other difference is that in Python, you'll get to see a nan, or not a number, a blank or a null value, whereas in Excel, you just see a blank cell. Other than that, it's pretty much the same thing. And again, minor presentational differences as well. Let's make this a little more complex. And this time, I want uh, I want to see many more things. I don't want to just see uh, the mean. I also want to see the counts. I want to see the medians. I want to see the sum, and so on. So I can do that by specifying an aggregation function. And when I do that, I basically get an extended pivot table that gives me separately mean, count, median, and sum. Uh, and let me draw some lines here, and let's make this bigger so we can see this here. So this is the initial information that we asked for. This is the mean. But then if you were to leave out just this part, just ignore this, then all of this stuff here is the same information, but with counts as opposed to the mean. And again, same thing here. We have the median. And then we have the sum here. And again, I'm not going to go into whether it makes sense to have a median or a sum or a count, but it tells us how many observations or whatever the aggregation function is that we applied. So this is how pivot tables work within Python. And we can also look at a slightly different example. There are many variations possible within pivot tables. So when it comes to aggregate functions, for example, here, I can specify a different aggregation function. So for example, for my diamonds data set, I can use the mean for depth. I can use the minimum and the maximum and the median for price. And for X, which is the table length, I can use the median. Again, I can use just about any function, including custom functions I may choose to define. So let's run this and we will predictably get a very large pivot table. But you can see that this is a lot of information that Python has been able to summarize for us in pretty much a millisecond. So, and the table is so large that it can't even display all the possible columns. So those have been replaced by dots. In such cases, what I tend to do is I tend to export this information to Excel and open it there because Excel makes it easier for us to scroll through information and do quick uh, uh, checks and reviews. And if you want to export this to Excel, all you have to do is to write to Excel at the end of whatever your data frame is, and you have to give it a file name. So let us just call it temp.xlsx. And when I do that, I can then open the file in Excel and look at what it looks like. And let's do that. And here is that file in Excel. Let's maximize it. And you can see we have all of the information that we asked for sliced and diced in the way that we wanted for each of the different columns. So there's a lot of data here. And again, a very quick way to summarize things and also be able to export this in Excel, something that would be useful if you have to share this analysis with a client or with your manager or with the rest of your team. One last thing I wanted to mention was that when you are building a pivot table, you have to be careful as to what columns you pick for your index and for the columns parameter. Generally, these should be categorical variables or something for which the count of unique values is not excessively large. If you were to pick a numerical variable, for example, or something that contains freeform text as your column or index parameter, you will get an unwieldy, very large pivot table that may mean nothing and will leave you confused as to what Python is doing. This warning applies not just to pivot tables, but also to pivot and group by, which is what we will look at next in this video. So with that, we are ready to move to the next function, which is pivot. Pivot is a simpler version of pivot table and really is a way to shape the data. Like for pivot tables, you pick what you need in the index and the columns and the value that you want to display in the middle. But unlike a pivot table, you cannot specify an aggregation function. Pivot will show you exactly what lies at the intersection of the row and the column values, which by definition means you should have only one value for each intersection of the row and columns. So what does that mean? Let's look at an example. And with that, let's run some of these cells. We create a data frame just like we have done before. We create a simple data frame which has 3 rows and 4 columns. So there are 3 animals, a cat, a dog, and a cow, some weight, height, and age. And we create a pivot with the index equal to animal. So we want to see cat, dog, and cow on the left uh, against the rows. And we want the height, which can assume 3 values, short, medium, and tall. And we want those as the column headings. And in the age, and we want to see the age as the value in the middle. And let's run this cell and see this is what we get. Now, notice how this has worked and how this is different from, uh, from pivot tables. You get all these nan values, which means these are blanks, because a cat doesn't have medium height. A cow that is tall has the age equal to really old, and that's what we see here, and so on. So here you will see that there was no aggregation function performed. There was no sum, no average, nothing at all. All it did was list down the value that existed at the intersection of tall, which is here, and cow. And it saw that cow and tall, and that answer is really old. So it just reshaped the data in a different format. That's really all it did. We can make the output cleaner. So we can replace the NaN values with blanks like so here. So we reproduce the same command, except that towards the end, we put dot replace nan with space. So that makes it easier to read. Now imagine, let's look at our data frame again. This is our data frame. Let's add another row to it. Let's duplicate cow. So now there are 2 cows with different weights and different ages. If we were to try to do a pivot of this, it will not know what to put in against the cow row. So when I come back to my pivot here, I find that for the cow, the system will get confused because there are 2 cows with different ages, and it will not know what to put in there, and we will, as expected, get an error saying that there are duplicates in the data. So when we run this, we get this big long error. When you get an error in Python, normally the best way is to look at the bottom, and that is kind of what will lead you to identifying what the problem is. And here we can see it says that index contains duplicate entries and it cannot reshape it. So which is what we would have expected. Next is crosstab. Crosstab is just really a frequency table. It gives you the counts at the intersection of specific values for your indexes and columns. What you can do with crosstab, you can also do with pivot table. However, I find crosstab to be extremely handy to use because the commands are very economical. You have to type very little, just give it the two column names and it creates a frequency table for you. And I find it very handy to use and easy to remember as well. So let's look at an example. Let's run some of these cells. So I have my diamonds data set as before. I have my 10 variables and I have 53,940 rows, and I can create a basic pivot table between cut and color. Sorry, I meant crosstab, not pivot table. I want to see the count of how many diamonds of different types of cuts and colors. And this is it. It is as simple as that. All I do is I specify the two columns that I want the crosstab on. And with this, the way I interpret this is that there are 2,834 diamonds that have the color D and cut equal to ideal. So that is how I read this. And this is very nice. And I might like to see the totals for both rows and columns. And I can do so easily by specifying margins equal to true. So I give the same command, the same function. And this time I get uh, total at the bottom and also here on the left. So that can sometimes be helpful. I can convert these to percentages as well by putting normalize equal to true. We run the cell and now we get percentages expressed as decimals. The grand total is still 1. This is across all of the observations. But sometimes I may want to see the percentages for individual rows or columns. And I can do that by changing the value for the normalized parameter. If I make it equal to index, what will happen is it will normalize by index. The rows will total to 1. And let's just run this and look at that. So now my rows total to 1. So there is no need to have a total column for the rows, but I still have my uh, total column, sorry, my total at the bottom for the individual column. So column D is equal to 12.5%, which is again the same as it was before here, and so on. I can also normalize by columns, and again, very similar idea. And finally, you can actually start to complicate crosstabs as well. Instead of just two columns, you can pass it multiple columns, and you have to provide those columns in lists such as this, and it will give you the answer. So here I have cut and color and by clarity. So my clarity is at the top and my cut and color are in my index, and I get 5 of these sort of subsets of different counts. And again, I can normalize, put margins equal to true, etc. So there's a lot you can do here as well. Next is group by. Group by is a very useful function as well. A lot of the functionality that group by provides can often be replicated by pivot tables as well. For people who have worked in SQL, they probably understand group by quite well, and I do not. But this actually group by does the split part in the split apply combine frame. So when you do a group by a particular field, it splits the data by that particular field and then allows you to apply different aggregation functions to each of the splits. So let us look at our MPG database, which is a database of 398 different cars. These are the names of the cars. Know that the MPG database, the MPG data set is different from the empty cars data set, which has only 32 cars, but this one is larger. So this is our MPG data set, and we can group the data by, say, origin as well as cylinders. And then we can provide an aggregation saying for displacement, which is this column here, give me the mean. For weight, give me the sum. For model year, give me the count. And for our acceleration, give me the median in seconds. So again, this is a very hypothetical example, not to say that any of these things really mean much for us, but we're just trying to see how the group by function works. And let's run this. And this is the response that we get. So we have grouped it by origin and cylinders. So first it considers origin. It splits the data by Europe, Japan, and USA. These are the three values for the origin. Then it's for each one of these splits, it splits again by cylinders, which is 4, 5, and 6. For Japan, it's only 3, 4, and 6. And then it gives us all of these different numbers, which are driven by what we specified here in this dictionary for the aggregation function. And aggregation function is given by the .agg here. Now, there are many columns in this data frame, and you would find that only a few were named here. So only if you name a column in an aggregation function will it be covered. Otherwise, Python is not going to display that. Pandas is not going to display that. So there you go. I removed acceleration, and then I get, again, the same thing, but without the acceleration column. You should play around with this, but again, this is not a spectator sport. As you change some of these parameters, you will see different things, different results, and you should absolutely explore this. Now, one interesting thing is that when I do a group by, it really doesn't do anything. It just creates those splits till I give it an aggregation function, which is when it actually does some work and gives you a response. So here I created a group by, which means I created those splits and I put them in a variable called group. When I look at what kind of a variable is group, it tells me that this is a data frame group by. And again, this is from Panda, so I can see that as well. So let me just change my display width to slightly wider. But let us see what my group actually contains. So if I do a list of the group, and this is what it tells me my different groups are. So this is my first group with Europe and 4 cylinders. The next group is Europe with 5 cylinders. And I also see other information. It says that this first group, this has 63 rows and 9 columns. And in the same way, it keeps going and it lists all the different groupings that it has identified in that group by. I can pick the first one as a data frame and I can list it like this. So this is my very first group, which is Europe and 4 cylinders. And which are the entries in my data frame that it contains. This is how I get to see it. But this, as you can see, is a very clunky way to pick an item in a group because I would not know what index values to use here. So what I instead can do is I can actually specify uh, the variables that I would like to, the values I would like to see, and the group I would like to see for those sets of values. So I use the get group function for the group. So I want to see for USA, I want to see all 8-cylinder cars, and I get to see them like this. So I can do this as well. You can see the first rows of every group. I can, again, slightly different. We can do the head, and we can do a describe. Just like we did describe for a data frame, we can do a describe for a group by group as well. And you can see the same kind of statistics, the count, the average, standard deviation, min, first, second, and third quartiles, the max, etc. And here, all we have done is that these two, which were sitting in the index, because we make out that this is an index because they are bold, we can move them as columns in a proper data frame. We can export this to Excel and play around with it there. We can also just see the size of every group, which means the count of uh, observations in each group, like this here. Next, I wanted to cover stack, unstack, and melt, which are sort of related. They are not directly related to the concept of split, apply, combine, but they're close enough. And this is a good place to talk about those. And again, we are going to look at an example to illustrate the concept. So, what we will create a dummy data frame, and that looks like this. So, it has two rows and two columns. So, we have a cat and a dog. Again, hypothetical weights. I have no idea how much does a cat or a dog weigh or what their heights are. I have neither of them, so I do not know. And when I do a stack of this data frame, this is what I get. So what it has done is it has taken all of my columns and moved them into rows, thereby creating a very flat and a very long list as opposed to a wider uh, data frame. So it took my weights and it moved them next here and it put all of them by the side. So this is what it did. So for a cat, it had two columns and it pulled them down and put the column names here and it put the values here. So this is what stack does. And sometimes this is useful to reshape data because we want to use it in a certain way or be able to filter things differently. When we look at what stack gives us, it gives us a series, not a data frame. Of course, we can easily convert it to a data frame as well. We can see the index, and this is a multi-level index, and you can see that here. We can convert this to a data frame. There's some bit of pandas gymnastics involved here. So my basic command is df stack, like so here, and everything else that you see here, let me use a red color. This is all just pandas gymnastics, and you can just look it up to see what we have done here, and it gives me a data frame. Again, we can do the same thing here. So let's stack the iris data frame. And this is again the iris data frame with 150 rows, 5 columns. When we stack it, we can expect 150 times 5 or 750 uh, rows in the resulting stacked data frame because every observation here is now going to have 4 extra rows. It will be split or exploded out into 4 rows, but it will be only 1 column wide. So that's what has happened here. So for observation number 0, the sepal length, width, and species, each one of these is here. So we have this, and there is another example here that we have with the empty cars data set. I'm not going to run this. I will ask you to give it a shot and also play around with the commands to see if they make sense to you. Very closely related to stack is unstack, but unstack is not the opposite of stack. It is the same as the stack of the transpose of a data frame. So let's just look at that word. So here is our empty cars data set. These are all of the entries, but this has been transposed. When you transpose a data frame, basically you convert its rows into columns and columns into rows. So let's look at what empty cars actually has so you can understand how the uh, transpose works. So this was my original data frame. And when I transposed it, it essentially moved all the rows into the columns and the columns into rows. This is what it did. If I do an unstack of my empty cars, this is what I get. But when I do a stack of the transpose of empty cars, I get the same results, which is why I say an unstack is the same thing as a stack, but applied to the transpose of a data frame. That's uh, what this is. And again, this is the expected row count with the actual row count compared. You would expect the number of rows as a result of a stack to be equal to the number of rows multiplied by the number of columns in the original data frame. Very similar to stack is melt. And unlike stack, which results in a series with several different index levels, melt allows you to freeze some of the columns so those do not get stacked. So you can hold tight some of the columns and just move some others that you are interested in. So let's just create a random data frame. Again, this is all random information. It has, for 10 people, it has the state, the gender, education, and some other characteristics. Again, these are all random numbers. They're not real. As you can see, they have just been generated with the random number generator. So don't apply any meaning to this. And let us melt the first 5 rows of this data frame, but by holding state and gender constant. And what that means is that I ask Python to hold on to this, not change anything here, but take the rest of it and stack it, which means bring them down to the level of each rows. And that is what we see in the answer. So I have melted uh, and I asked it to hold state and gender static, which means to not change it, not touch it, leave it as it is wherever it is, which is what it does. And I do that by specifying the index variables parameter, and those show up here, and everything else gets converted into this variable value uh, pair. So computers, so the Florida female has computer equal to 1, then computer equal to 3 for the next one, and so on. Now in this case, I don't see all of the other columns because I have specified the value vars to be just these 2 columns. If I had specified additional columns, I would have seen more. In fact, let us just do that in a cell here. We will copy this, so which means we are not going to specify the value vars here, and we will insert a blank cell, close the bracket, and we see that we not only have computers and income, we have education, housing, height, weight, income, everything. So there are 30 rows in this melted data frame. Melt allows us to convert wide data to long data, and the opposite of melt is pivot. So you can move this back using pivot as well. So we have seen many different ways with which we can explore data. We saw how to apply descriptive statistics to a data frame, to tabular data. We looked at split, apply, combine, pivot tables, how to summarize information, how to pivot it, how to do crosstabs, group bys, and so on. And one final thing I wanted to show was something called Y data profiling. This used to be called Pandas Profiling in the past, but is now called Y data. And there is a very interesting function there called profile report, which we will look at. And what that allows us to do is to perform uh, uh, exploratory data analysis very quickly. So most of the common questions that we might have on data, they are automatically and programmatically answered by uh, this library. So let's run a profile report on the diamonds data set. We load the data set. Our data frame now has uh, all of our diamonds information. Let's just pull it again. Let's see what it looks like. Again, we have all the 54,000 different rows, 10 columns, and we can run the profile report on this data frame by just uh, typing in profile report df. We have to write minimal equal to true just to avoid running out of memory, because then it has to do a lot of work calculating correlations. For most smaller data sets, you should be able to run it with minimal equal to false, or just completely not having this parameter at all. So let's run this. And as we do so, you see that it takes a little bit of time and it creates a report for you right here in your Jupyter notebook. And you can see how many observations are there, the number of variables. For each variable, it tells you how many distinct values are there, how many missing values, what does the distribution look like. You can click on more details and it expands to show you more information. and so on. You can pick a particular column that you're looking for through the drop down here. And again, this is very intuitive and gives you uh, really good information. You can actually output all of this to an HTML file, something you could then share as a standalone file with your clients, with your customers, with your managers, other people in your organization. Let's do that next. We will create a file, and this file will be called output.html. And what I'm going to do is I'm going to open this next once the file has. And this is my file. And as you can see, the output.html, this file appears in my data folder here, output.html. I can put this as an email attachment, send it to anyone I like, and it has all the same information, probably rendered even better because it's in a browser for all of my variables uh, that we saw. So again, I would encourage you to use such automated tools in Python that can help you tell the story behind the data very quickly. With that, we are going to end this lesson on exploratory data analysis. Next, we are going to cover visualization. So please practice the commands and the functions that we have seen. And there are many more than I have covered in this brief video that you should be able to find and explore. Uh, Thank you very much for joining, and see you in the next video.